Heating and air conditioning contactor, normally located on the outside condenser. There are two scenarios. One could have a large box with everything encased in the box with the heating and air conditioning outside. This may be referred to as a package unit. The second scenario would be a condenser with two copper lines feeding the condenser, and once the two copper lines feed the condenser, the inside somewhere on the outside, usually it's a little part, you'll take the little metal part down, remove the 5/16, generally 5/16 screws, and remove that, and then this would be exposed. Normally this side here, one side would be hot at all times if the electricity is in normal working conditions and optimum conditions. So what happens here, we have a low voltage side here, and here we get a hot side and a common side, and it energizes. When the contactor's been energized, it pulls this down. Okay, once it pulls this down, then simply put, the voltage, if you put your voltmeter here and here, you may read 120, 120. Collectively, this would be 240 volts. If you put under normal circumstances, if you put your without being energized, your volt leads here, you may read 0 and 0. However, if it becomes energized through the 24 volts, which is each side, one side being the hot, perhaps the other side being the common, whether that be a yellow wire, red wire, and then a blue wire for your common wire. But then it pulls this contact in and it makes contact. At this point, one should be able to take and put their multimeter leads on this particular spot, and you may read, say, hypothetically 240 volts. Question is, if you go outside and you notice that your thermostat has hit the set point, so to speak, meaning that, say, if you have your thermostat set at 68, it achieves that 68 degrees. You hear it maybe make a little click, a little clicking sound. It turns off. So it turns off, say, hypothetically, 20, 30 minutes later, the system hasn't come back on, and you walk outside, and when you walk outside, you notice the system is still running, and even if you altered the temperature on the thermostat, or if you just simply cut the thermostat to the off position. And if you did either or, the thermostat shouldn't be sending the power to the low voltage side here, the 24 volt side. So in this particular case, then what would happen is basically then okay, the system is running, and you're like, this is not making any sense. This is a strange phenomenon. So if you take your meter leads, and when the system's off, it should be reading perhaps 0 here, 0 here, and then 120 here, 120 here, the incoming voltage, the load side. This, we'll call this hypothetically the line side, call this the load side that feeds the load, which would be the condenser, fan motor, and compressor. So now you put your leads on one, you put your leads on the other. Once you put your leads on these, then you're reading 240 volts. You're like, wait a minute, this is making no sense. So, okay, and I'm not certain if you put your leads on here, say if you read nothing on here, there's perhaps no voltage on the energized. You're saying, well, what happens in this particular case? The fan motor's running, the compressor's still running. The contactor may be bad. So in a scenario like this, which simply means that this little plunger thing that makes the contacts here may be stuck closed or welded shut. Sometimes the heat, ants, and various other things get to get up in here with the vibrations and the and I'm not certain what all the ramifications are. But say if this were pulled in and not returning, the system's going to continuously run. So you need to have your HVAC tech, or perhaps get somebody. If you're doing it yourself, that's on you. But but the contactor may be bad, and the contactor may need to be changed. So again, if scenarios, thermostat's turned off or meets the set point, no low voltage here, you go outside, the system's still running. 30 minutes, an hour later, it could be a telltale sign that this contactor is welded shut and is allowing power to move from one side to the other side. Hence, the contactor may be considered bad and would need to be changed by whomever whomever the individual gets to change it or whatnot. But you need this contactor in that particular scenario may need to be changed, because if not changed and it continuously and incessantly runs just for hours and hours and days on end without a break, it could get the compressor too hot, it could overload the fan, and it could burn out the fan, and worse, if it burns out the compressor, then that could be quite pricey. Anyway, contactor that's the contactor that's feeding voltage after while there's no low voltage supplied and continuously running may portend a bad contactor for your HVAC system, your condenser. Thank you for watching, and have a great day.